All right, Unit 6, Lesson 17, Comparing Transformations. So for each pair of graphs, be prepared to describe a transformation from the graph on top to the graph on the bottom. So for the first one, we have translated to the left one. So translate left 1 unit, and then we reflected over the x-axis. And then we translated down 3 units. All right, let's take a look at the G functions. Let's see. We reflect over the x-axis. And then after you do that, it looks like that. Oh, that's not a very good. So when you reflect over the x-axis, it's going to end up looking like that, although I can't draw straight. So then we need to shift down. So we're going to translate down. And let's see, that looks like 4 units. All right, and then let's take a look at the H functions. We are going to translate left 1 unit. And then that's a 1, not an L, 1 unit. And then reflect over the x-axis. And then, let's see, after we do that, we'll have this point, and it'll be going down like that. So then we're going to shift down 3 units. All right, so let's take a look at 17.2. It's an info gap. So we are going to take a look at the problem card and the data card together. All right, this is a little bit more challenging, so we're going to take it step by step. So we have this original function where p of theta is equal to sine of 2 theta plus 3. So they've taken the regular sine graph, made the period shorter, basically cut it in half, so 1 period is pi. And then they took the midline and raised it 3 units. All right, so let's take a look at the information that we know. We'll start with the graph. And so here is our grid. Okay, so it's a vertical translation up by 2 units, no horizontal translation, vertical scaling of 4, no horizontal scaling, and then it says we translate first and then stretch. So the first thing we're going to do is move it up by 2. So now the midline, there's our midline, and now it looks like it's at 5, but remember we are vertically stretching by a factor of 4, so it's actually going to be at 20 because 4 times 5 is 20, right? And since our vertical scaling, our amplitude, it was 1 here, and we are scaling it by 4, we're going to go up to, this is going to be 4, right? So if this line is 20, then this is going to be 24, right? So it's going to look something like that. I'm not very good at drawing. And then the period, oh, that's really bad though. Let's try to fix that. All right, so there, maybe that'll help to make it a little more. All right, and then remember that one period was at pi, so that's 2 pi. All right. And so let's get that out of the way. So our function is going to be, remember it's q, so q of theta is equal to, and we had our original sine of 2 theta, and it was plus 3, but we moved up 2, so plus 5, but then we multiplied the whole thing by 4 because it was a vertical scaling, so we're multiplying the entire output by 4. All right, now let's take a look at problem card 2. So we have function r, which is negative cosine theta plus 3. And here we can see the graph. And we had a midline at 3. There's our midline. And the amplitude was 1. And it was flipped upside down because it was negative cosine. All right, so S, we have no vertical translation. We have a horizontal translation left, so that means we're adding pi. No vertical scaling. We have horizontal scaling of 1 over pi. All right, so let's draw our y and our x axes. I'm going to make this go up to 4. And then 1, 2. Okay, so we had a horizontal, so we know our midline is still at 3 because we didn't have any vertical translations or anything. Our amplitude is still 1 because there was no vertical stretching. Because we're translating left pi units, we're going to bring our maximum all the way over here. And then our horizontal scaling is 1 over pi. So since our period was 2 pi, and if our horizontal scaling is 1 over pi, then basically we are taking that 2 pi and dividing by pi. And so our new period is going to be 2. And so we're going to end up here, and then our minimum will be, oh, that's not right. That midline is at 2, not 3. It's supposed to be at 3. All right, and then that will go there. And then our x, or our midline, so it's going to look like this. Okay, and so our equation will be S of theta is equal to, it was still negative cosine, but we shifted it, pi theta plus pi, and then plus 3. Because we did our horizontal translation first, and then we did our horizontal scaling. All right, let's take a look at 17.3, match the graph. All right, so identify a transformation that takes f to g and write an equation for g in terms of f matching the transformation. Okay, so we have shifted, so our midline has gone from the x-axis to 3. So it's a vertical shift up 3. Our amplitude was 1, but now is 2. So we have a vertical stretch of 2. All right, let's see. We have a horizontal scale factor. And actually, well, that's fine. We have a horizontal scale factor. And that is going to be, since we did have a period of 2 pi and now it's 1 pi, that scale factor is 1/2 because it's half of what it was. So that horizontal scale factor is 1/2. And then we had a translation since we were starting at the maximum there and it has shifted over here, that is pi over 2. So a horizontal translation to the right, pi over 2. All right, so what does that look like as far as the equation is concerned? So g of x equals 2 times f of, and then whatever factors are getting plugged in there. Okay, so we had a vertical scale factor of 2, and that was here. We also had a vertical shift up of 3, which is that. And then we had a horizontal scale factor of 1/2. So that actually means we are multiplying by 2. And then, sorry, my dogs are growling at each other. We translated to the right, so that's minus pi over 2. And there is the equation for that transformation. Again, if our horizontal scale factor is 1/2, then we are multiplying by 2, because remember, if we have 2 pi over that 2, then our new period is pi, which is half, that's the scale factor, half of the original 2 pi, right? So it's basically like you're taking 2 pi and multiplying by the scale factor to get the new period. All right, so let's take a look at another transformation. Okay, the 2 next to the x, right? And then this one should have the 2 outside, because when you look at that, if you were to distribute this, you get 2x minus pi over 2, which is the same thing as the previous one. All right, and then there's your lesson summary if you want to take a look at that.